Now we're going to look at part 2. All right. So in part 2, it says that the normal, which is a straight line to the curve at the point where theta equals to alpha, meets the x-axis at point A. Show that the x-coordinate of A is k alpha, where k is a constant to be determined. So let's try to understand what the question is asking. So you're supposed to find the x-coordinate of the point A. All right. So point A is where the normal cuts the x-axis. So let's make sense of it by first drawing the graph. So you can actually use your graphing calculator to draw the graph. So take note that when you draw the graph, the window value, you need to set it such that t minimum is 0 and t maximum is pi, because in the question you are given that theta is between 0 to pi. So you need to set the window value to this instead of using the default values. Okay. So after you have plotted the graph looks something like that. Okay. So we have a point, a general point, theta equals to alpha. So try to understand the meaning of parametric equation. So this means that if you are given a parametric equation of a curve, this means that in general, this is the x coordinate, this is the y coordinate. So when we have theta equals to alpha, all right, this is called the parameter. When the parameter is equals to alpha, then the point they are referring to becomes the point where x is 2 alpha minus sine 2 alpha, and the y coordinate of the point is given as 2 sine alpha squared, right? So this is the meaning. Okay, so in general, there's a general point. Suppose the point is here. So this is the point where theta equals to alpha, and the coordinates is given by this. Okay, so we draw a tangent, then a normal. So this is the normal, and where the normal meets the x-axis at A. So this is the A that the question refer to. So we are supposed to find the x-coordinate of A. So since point A lies on the x-axis, that means the y-coordinate is 0. So now we make sense of things. So we will start. Then we need to actually find the equation of the normal first, because without the equation of the normal, we wouldn't know how to find the point A. So basically, the steps would be first, find the equation of the normal. All right. Then try to put in y equals to 0 into the equation so that we can find point A. All right. So we're going to first start finding the equation of the normal. So we are finding the equation of the normal at theta equals to alpha. All right. So therefore, the equation of the normal will be minus 1 over the gradient of the normal will be minus 1 over the gradient of the tangent at theta equals to alpha. So the gradient of the tangent, all right, at theta equals to alpha is given by cotangent alpha. So we have found out what is dy dx in part 1 already. Dy dx is cotangent theta. So now at this point, theta equals to alpha. So we will substitute. All right, theta to be alpha into our expression to find the gradient of the tangent. Okay, so this gives the gradient of the tangent. So gradient of the normal at theta equals to alpha will be then minus 1 over cotangent alpha, okay, which is equals to tangent alpha, because cotangent is 1 over tangent. So now we're going to find the equation of the normal. So we're going to use the formula y minus y1 equals to m. M is the gradient of the normal, x minus x1. Okay, so the y1 x1 will be the point, all right, where the equation of the normal is on the curve. So the point is given by this point. So this is our y1 and x1. So we have y minus 2 sine alpha square equals to gradient x minus 2 alpha minus sine 2 alpha. Be careful in your algebraic manipulation. If there are brackets, you write the brackets first before you expand it. So let's simplify a little bit. So we can write this as sine alpha over cosine alpha, because everything seems to be in terms of sine and cosine. We also convert this to sine and cosine. So this will be minus 2 alpha plus. So take note of the sign. All right. So we are done. First step. Okay. So the second step is we want to find coordinates of A. So to find the coordinates of A, we will substitute y equals to 0, because at A, all right, what the y coordinate is 0. So you're going to substitute y equals to 0. So let's explain. So instead of just substituting, immediately try to explain a little bit. So this would be 0. So what is our end in mind? Our end in mind is to find the x coordinate, right? So to find the x coordinate, that means we need to solve for x. Okay, solve for x. So how do we solve for x? So let's try to make x a subject. So we'll multiply throughout by cosine alpha. So let's expand this. So let's isolate the x term. Okay, so let's do a check for algebraic manipulation first. All right, so now we're going to isolate x, find x. So many of you will say that, oh, can we just divide throughout by sine alpha? Okay, but very important, yes, you can, provided sine alpha is non-zero. So you need to verify that first. Okay, so let's verify if sine alpha is really non-zero before we do the division. If not, you can't just divide by sine alpha if sine alpha can be 0, because you'll be doing division by 0. Okay, so let's do a check. So when is sine alpha 0? Sine alpha is 0 when alpha is 0 or pi, because we know that theta is given in the question is between 0 and pi. So this also means that since theta equals to alpha, so alpha should also be between 0 and pi. All right. So sine 0 would be sine alpha equals to 0 when alpha is 0 or pi. Okay. So when alpha equals to 0 or pi, so let's see what happened. We realize that tangent alpha is 0 because tangent alpha is sine alpha over cosine alpha. So when alpha is 0 or pi, then tangent alpha is 0. So what is the implication of tangent alpha equals 0? Okay. Recall that the gradient of the tangent is cotangent theta or cotangent alpha. All right. So which means that when or rather, okay, maybe we look at the gradient of normal, okay, since this question talks about normal. So we know that the gradient of the normal is minus tangent alpha. So if tangent alpha is 0, this means that gradient of the normal is 0 because it's minus 0, so it's 0. So what is the implication? We have the gradient of the normal is 0. Gradient of normal is 0 means the normal is a horizontal line, right? And since just now we substitute y equals to 0, so not only the normal is a horizontal line, the normal is actually a horizontal line where y is 0. This means that the normal is the x-axis, coincide with the x-axis. So you have this case where our graph, so your normal is like that, right? Your normal. Okay. So if your normal is like that, then it doesn't make sense to talk about point A because it doesn't like the normal doesn't cut the x-axis at a particular point. So hence, we say that alpha cannot be 0 and alpha cannot be pi if we were to want to talk about point A. So this means that sine alpha cannot be 0. So we have verified that sine alpha is non-zero. So now we are going to divide throughout by sine alpha. So we have x, and then this we have 2 sine alpha, cosine alpha. Then we divide by sine alpha, we get 2 alpha for this term. Then for this term, we have sine 2 alpha. And finally, we see the relationship between these two terms. This is double angle formula, 2 sine alpha cos alpha. So finally, this is equals to 2 alpha. So therefore, k is 2, shown. Right?